Have you ever actually stopped to wonder what's going on behind the glass when you tap a link and boom, a specific app just seamlessly opens, or your phone instantly starts dialing a number? I mean, we completely take it for granted, right? But every single time we tap our screens, there is this absolutely fascinating, highly orchestrated, and totally invisible system making the whole shebang happen. So, welcome to The Explainer. Today, we're demystifying URI schemes and deep links so we can finally understand that hidden architecture. Let's dive in. So, where do links actually go? Well, I want you to imagine a chaotic confusion world for just a second. You tap a familiar link in an email, maybe a phone icon on a website, or a chat bubble in a friend's profile. Your finger leaves the screen, and in that literal split second, a wildly complex negotiation kicks off. The text on your screen actually has to be translated into a physical action on your device. It doesn't just magically happen out of nowhere. It has to be deliberately routed. And that routing, it happens deep inside what we can basically think of as the OS routing hub. Think of your device's operating system, whether that's iOS or Android, as the central glowing brain. It sits right there in the middle, catching all of these incoming links and taps and instantly deciding exactly where to send them. It's essentially the ultimate air traffic controller for your digital life. It parses the invisible code behind every tap you make dozens, if not hundreds of times a day.
Section 1. Locators versus action triggers, the core framework. Okay, to understand how the OS manages all this traffic, we really need to break down the language it speaks and the fundamental difference between the two main categories of routing behavior.
So here's the core dichotomy of how things move around on your device. Think of it like two different lanes of traffic. On the blue lane highway, we have hierarchical locators. Now these exist solely for retrieving resources. They fetch things for you to look at. But over on the green lane, we have action-based schemes. These are your command triggers. They aren't fetching a web page at all. They're actually commanding your device to physically do something. Let's break each of these down so you can spot the difference out in the wild.
Let's look closely at the syntax of a hierarchical resource locator, or what we all know as a URL. The format is scheme followed by a colon and two forward slashes, then the host and the path. You see those two forward slashes? That colon // That is your absolute dead giveaway that you're dealing with a locator. Everyday examples like https:/example.com or file / use this exact structure to locate and retrieve specific web pages, app screens, or files securely stored on your system. It's simply an address pointing to a destination. Now contrast that locator with an action-based URI scheme. Notice what's missing here? There are absolutely no forward slashes. The format is purely scheme data. So, for example, you have tell followed immediately by phone number or mail to followed right away by an email address. The total absence of the // is a really crucial difference because this format tells the operating system, hey, don't go looking for a web page. Instead, execute this direct command right now using the data I just gave you. These are incredibly powerful triggers for system-level actions. Honestly, it really comes down to this. URLs locate resources, URI schemes trigger actions. If you take away only one single concept from this entire explainer today, please let it be this one. This is your foundational anchor point, because once you grasp this critical difference between locating a destination and triggering an action, the rest of the routing mechanics we're about to explore are going to make perfect sense.
Section 2. Native OS action schemes. The core commands. All right, now that we know how action triggers are actually formatted, let's look at the specific built-in commands our devices recognize right out of the box.
We're back to our operating system again, but this time it's acting strictly as a traffic hop for these action triggers. The OS decides the final routing based on its own core programming. It looks at the action scheme, it checks what default apps you have installed, it verifies your user permissions, and then it executes the command. It is a highly controlled environment where the OS knows exactly what to do with the commands it was born with. There's no guessing game here at all. And here are those core actions. When the OS sees tell : boom, it instantly opens your dialer. When it sees mail to : it launches your default email client. Pretty straightforward, right? But there are some really important nuances here to keep in mind, and this is exactly where things get interesting for developers. For instance, the SMS scheme opens your messaging app, sure, but it has super limited reliability if a developer tries to include pre-filled text content. It just doesn't always translate perfectly across different devices. Similarly, the geo scheme opens maps, but the exact behavior in which mapping app it actually prioritizes varies heavily depending on whether you're holding an Apple or an Android device. Section 3. The custom app chaos. Unstandardized routing.
So the core stuff works great, but what happens when third-party apps decide they want in on the action?
Well, to bypass the browser entirely and launch directly into their own curated experiences, developers started creating custom app schemes. You've probably seen these hiding in the background of web code, stuff like Spotify// or WhatsApp//. Now look, when you have the app installed, these work beautifully. The app registers its custom scheme with the OS traffic cop the moment you install it. But, and it's a massive but, because these are completely unstandardized, there is a remarkably high risk of failure. If you tap a link that fires a Spotify// scheme, but you don't actually have Spotify installed on your phone, nothing happens. Literally nothing. You just hit a dead end. Or worse, you get an ugly error message. It leads the user straight into a digital void, and nobody wants that.
The real underlying problem with custom schemes is that there is absolutely no universal fixed list beyond those core OS-defined ones we just looked at. The routing behavior on your device right at this very moment is entirely dependent on your specific platform, your exact OS version, and the unique random combination of applications you happen to have downloaded. It's a highly fragmented, chaotic way to route users because it relies entirely on the blind hope that they already have your specific software installed.
Section 4. Modern Universal Deep Links. HTTPS-based routing. Thankfully, the industry realized we couldn't just keep dropping users into digital voids. Developers desperately needed a fix. To solve all this chaos, the mobile industry introduced a modern replacement layer that acts as a universal HTTPS bridge. Now, you might know these under a couple of different names, like App Links if you're on Android, or Universal Links if you're on iOS. Instead of using a custom, unstandardized scheme like WhatsApp/, developers went back to basics. They went back to the standard, secure web locator format HTTPS, examples like wa.me or open.spotify.com. Think of this as a sleek bridge made of light that connects the broad, open web directly to a specific app. Let's walk through how this actually builds a perfectly seamless experience using what we call fallback bridge logic. Step 1, you click a standard HTTPS link. Step 2, your OS pauses for just a fraction of a second and checks a highly secure file to see if you have the verified app installed for that specific web domain. And step 3, well, that's where the magic happens. If you do have the app, the OS intercepts that web traffic, hands you off, and launches the app directly. But, and here's the kicker, if you don't have the app, there's no digital void, there's no error message, because it is fundamentally a standard web link. It simply falls back to your mobile web browser and loads the web page perfectly. It's this incredibly intelligent handoff that absolutely prevents broken links. So, as you can see, we've successfully moved from total fragmentation to one unified network. We have URLs dependably locating resources out on the web. We have specific URI schemes triggering those core OS actions, like phone calls and emails. And sitting right on top of it all, resolving that messy custom app chaos, we have universal links providing the ultimate bridge, safely guiding us to an app if we have it, or smoothly transitioning us to a web page if we don't. It really brings this beautiful, stabilizing clarity to a wildly complex system.
Which leaves us with a final, kind of provocative thought to chew on. How much do you really control the invisible routing in your pocket? Every single time you tap, thousands of lines of code, verified app checks, and OS permissions are being negotiated in fractions of a millisecond. You might just think you're tapping a link to share a cool song with a friend, but underneath it all, you are activating an incredible invisible routing system operating flawlessly beneath your fingertips. Thanks for exploring this hidden architecture with me today, and I'll catch you on the next explainer.